Thank you all for being here. We're delighted to have the opportunity to speak with you today. My name is Kyle Stromberg. As mentioned, I work for G&W Electric. I am one of their global product line managers, and I am responsible for all of our solutions that are connected to buried underground distribution power cables. Did you push up on the bottom there?
Hello, there it is, okay. So I'm Ron Pate, and I am Kyle's peer, and I have responsibility for the overhead products, which includes a lot of reclosers. And so as more systems become hybrid, I'm going to join Kyle in talking about some of the risk and considerations when you look at these hybrid systems where you may have reclosers and underground cables.
Okay, so as Ron mentioned, we have seen an increase in the prevalence of our customers in both transmission and distribution level voltages transition their circuits from being either solely underground or solely overhead to systems that require you to transition at points on that same circuit. So maybe one piece is overhead fed, and then it transitions underground for a piece of that circuit. And that does create some unique considerations from a protection standpoint, and that's really what we wanted to focus on today, specifically reclosing, a functionality that's very common on overhead systems, and the impacts on a system where you have both overhead and underground product. But first, let's review a little bit of what's driving more undergrounding. Okay, so we mentioned two different ways to carry these circuits, and we certainly have seen a trend in the industry of more power cables being put underground. Why is that happening? Probably the biggest driver that we've seen is the need for increased resiliency. It is no secret that we are seeing throughout the world more and more high impact, low frequency weather events that are capable of causing a lot of disruption to our power grid operators. Okay? Undergrounding circuits can certainly help in those situations by preventing this circuit from being impacted by some of those storm elements. Of course, there's a safety impact as well. Putting a cable underground eliminates the chance that if it's a uninsulated cable on an overhead line, people, animals, things can't come into contact with that cable as easy, and certainly that can improve general public and line operator safety considerations. Another hot topic over the last 5 years, and there was no pun intended, but wildfires, right, have been increasing in frequency throughout the world. And to address wildfires, one of the most important things that we need to do is to address sources of ignition. Putting buried underground cables is preferred over overhead cables, where again, if there's a fault on your circuit and there's any arcing or sparking on that overhead cable that could drift down and ignite something, that could be a challenge that starts a wildfire. From a maintenance perspective, again, burying that underground cable generally will limit the lifetime maintenance costs. You insulate that cable, it's buried, and it's not expected to be maintained over the course of that life. Whereas overhead circuits, there may be maintenance requirements to keep that line working effectively. For example, tree trimming, and ensuring that foliage isn't growing over and touching those lines. Okay? And that kind of feeds into that last point, less vegetation-related outages. So when we're looking at operating both transmission and distribution systems, obviously faults have a major impact on that system, but not all faults are created equal. Okay? There are differences in these types of faults, And as a result, the resulting protection equipment used on overhead and underground circuits do have some differences. Okay, so I want to talk a little bit about that. So I'm going to start with talking about what are some of the causes for faults on underground circuits and cables. So first, again, you can see on this picture on the left here, if you ever want to, dig a hole in the ground, best practice in most jurisdictions is you need to check with your local utility company before you dig to ensure that you're not going to come into contact with one of those buried underground cables. Underground cables are very reliable. Once you bury them and they're underground, typically there aren't a lot of things that can come into contact with them, but that doesn't mean that there still aren't instances that occur where someone digs, machinery damages the insulation of that cable and creates a fault. Okay? So that's more of a impacted by people event. There certainly are other reasons why underground infrastructure fails. So over time, the insulation around that conductor, it can degrade, and that can happen for a number of reasons. First, just general aging. These products are typically designed to last lifetimes of anywhere from 20 to 50-year lives, depending on that technology, but over time that insulation can wear down. And one of the things that can wear that insulation down is actually faults occurring on that system, stressing that insulation. Depending on the type of cable system and its age, moisture can find its way into these circuits. Of course, below ground, there's going to be access to moisture from rainfall. And if water can penetrate into this insulation, it can cause treeing and other effects that can degrade that insulation and create a failure. On older transmission systems, paper insulated cables, there's still plenty of that installed. I know in North America, one of our main markets. But as that paper dries out over time, it's typically impregnated with a fluid and oil. And as that paper dries out, it can create voids which can cause discharges and failures of that cable. And then last but not least, excessive heating. So if you're using over-dutying your circuits with more current than it's rated for, and the impacts of faults, where there's short circuits and short amounts of high energy can degrade that cable insulation. One thing that's common in all of these is typically when you have an event like this, it's a permanent event, meaning that short circuit is not going to heal itself without repairing that insulation. So we call that a permanent fault. Okay? It's a little bit different than what we see on overhead systems. So I'm going to transition over to Ron, who's going to talk a little bit about overhead faults.
So as Kyle mentioned, when you have overhead, there are many situations that can occur. Unlike on the underground, when you have an overhead fault, it could be that that fault will self-clear. In fact, some studies have been done, and in some studies it's indicated that reclosing, where you can do automatic reclosing on these overhead lines, you can actually see up to 95% of these faults self-clear. A limb falls, then it drops off the line. Cables might touch when the wind is blowing, etc. And so let's talk about what some of those causes of overhead faults are that reclosers might be able to help you solve without having the lights actually go out, which is what's driving the use of reclosers prolifically across the planet. So ice and snow loading, in some areas you have very cold temperatures, might not be here in this particular region, but you can have ice loading, snow loading, and this can cause issues. You could have transformer short out, for example, on a line, etc. You can have high winds. These high winds, depending on the cable tension, might allow the cables to swing and touch one another. Well, clearly that's going to self-heal and clear, and so by using an automatic circuit recloser, you can avoid having that result in an outage that would have occurred if the substation breaker had to trip, for example. Trees. Many areas, I'm from North Carolina in the east of the United States. If you've ever been to the eastern, southeastern United States, we have lots and lots of trees. We also have lots of squirrels that live in these trees and love power lines. So trees, and if the growth gets too close and a limb can fall on top of the power line, often that will self-clear. And it might take 1 or 2 recloses for that to actually happen, but it allows you to increase your system reliability significantly by using these reclosers. And then birds and animals. So you may have birds climb on, you may have an animal, a squirrel or some other type of animal get on some apparatus like a distribution transformer, and it may short out, but that short will clear. The squirrel will become an airborne flying squirrel, and it will clear itself from the transformer, and so the recloser can restore power automatically. And as systems transition from totally overhead, which is what historically we've had, to these underground type systems for all the reasons Kyle mentioned, you have to start to take into consideration, what about the reclosers I have? You also may have areas where you have these type of threats to your overhead line having faults. You may have a lot of undergrounding in that area, and you might be a little bit concerned or nervous about putting reclosers in those areas. But the thing we're going to talk about in a bit is the fact you can coordinate for that. So when you're reclosing and you have a hybrid system, meaning you have overhead lines and then you have underground lines, you do not want to reclose on a fault that's under the ground. This is, as Kyle mentioned, right? This is a very bad idea. We're going to talk about that. So what is really, really important is before you reclose, and this requires coordination in your system, before you reclose, you need to know where is the location of the fault, and there are ways to determine that. Because if you do reclose on that underground cable and it's a bolted fault, a permanent fault, really bad things can happen, depending on the amount of energy that is pushed through that system. But there is technology, and this is an area that we build both underground and overhead, and we even build pad mount switch gear where we can put a recloser in the switch gear as well as the switches for the underground feeds. So we're experts and can help you appreciate this, hopefully, by having this conversation, that you can choose technology that can do this, advanced reclosing, but you can also have the proper coordination to make that successful and to eliminate these risks to the max extent possible. And this becomes even more important when you look at the fact that now technology is increasing so that there are actually now reclosers available up to 72 kV. These are sub-transmission levels. Obviously, if you have a recloser with 31,000, let's say, amps of fault current at 72 kV, huge amount of energy. If you have a hybrid system and that happens to be a permanent fault, that amount of energy, if you reclose in on that line, can be extremely devastating. It could be a huge safety risk, etc. So we'll talk about that. So let me share really quickly an actual cautionary tale. I cannot tell you where this occurred at, but there was a 72 kV line, and this particular line had high pressure fluid filled underground cable in the underground portion, but it had an overhead line, and it was going into that through that feed, and they had a fault. They did not properly determine where the fault was located, and they reclosed back in on that permanent fault. And the pictures of this are extremely moving, let's say. It was a huge explosion occurred because of this. And it took nearly 3 months to repair this. Luckily, in this particular situation, no one was killed, but this could have been a very big safety risk. There was a lot of equipment damage, etc. So please take this very seriously. Don't be afraid to have overhead and hybrid systems. They're becoming more and more popular. Don't be afraid to reclose, but be very cautious about the coordination, and we can talk a little bit more now.
So when we sat down as a solution partner with this utility that had this issue and started to brainstorm, how do we prevent something like this from happening again? Of course, there were many different opportunities and ways that we could address this challenge. Ultimately, as Ron mentioned earlier, the most critical goal of the solution that we were working on was identifying the source and location of that fault. Now, in our industry, there are a number of different techniques, technologies, approaches in which you can identify where that fault is occurring on your system. What we ended up using for this application is a differential protection methodology. So Ron mentioned reclosers, right? So devices with integrated CTs on the line. So this particular utility had a device like this at both transition points where the circuit was transitioning from overhead to underground, which gave them the ability to measure real-time current information at that transition point. So by doing that, they were simply able to take advantage of digitalization techniques and use their relays and their SCADA system to communicate information back and forth between those two devices. And a differential protection scheme is essentially looking at the section between those two devices, and if the currents are more or less equal, we know that the fault is not in that section, okay? If they see an imbalance or a difference between the readings on those two devices, they're able to identify with high confidence, yes, we have a fault on our underground circuit. And as we reviewed earlier, if it's on the underground circuit, it's likely going to be a permanent fault and not a fault that we would want our recloser technologies that may see that same fault when it occurs to reclose back on, okay? So at G&W Electric, we talk a lot about the 3 Ds, decarbonization, decentralization, and digitalization. And this is a great example of how digitalization is helping our customers solve problems on the grid. So again, by taking advantages of open standards in the industry, IEC 61850 is a standard that has a number of different protocols and functionality, but within it there is a messaging protocol called Goose that allows for very high-speed communication between different IEDs, relays throughout your grid, and they were able to create a scheme where they're able to detect through that differential protection where the fault is, and then communicate a block signal to that relay on the recloser to ensure that it does not operate again and prevents them from having a very serious failure like they did. Right? When we did the retrospective with them and we talked about if this scheme had been in place, what would have been the impact? Well, they still would have had to repair a section of cable that had that fault, but the repair likely could have been done in a few weeks as opposed to that 3-month impact because of all the other equipment damage that was done from that fault. So definitely an area that we thought would be a good example to come and share. There are many, many increasingly more complex problems that we have to solve due to the changes occurring on this grid. And again, if we use that 3Ds framework, we're very confident that we'll be able to come up with solutions to help solve them.
Okay, so our last slide, just a couple of quick takeaways we want to share with you. As mentioned, the energy density in the grid is getting more and more. You're having to increase voltages in order to be able to deliver the amount of energy to the locations where you need it. So technology's evolved, and now you can do reclosing even up to 72 kV. In fact, there's a 72 kV recloser down at our area. And that means this problem and the risk of this is increasing. So that's why I wanted to give you this cautionary tale. Do not reclose on underground. Do not be afraid to put up reclosers, and if you have them, use them, but do not reclose on underground. Make sure you work with your providers, your technology providers, get the advice, make sure you have the automation, the blocking schemes, the detection methodologies, know where the fault is at before you reclose, and then you can do so safely. So we really appreciate your being here today. We will be, if you would like to talk to us further, we're at AD01 down the hall, and we hope this has been helpful for you as a reminder about hybrid systems that are growing. Thank you.
Thank you so much.
Thank you, Carl and Ron, for your wonderful sharing.